Hi there, my name is Martin Wickfors and I'm responsible for corporate communications at PowerCell Sweden. Welcome to this webinar. Today we will be discussing fuel cell-based power generation for the marine segment. Joining me are our three experts, and actually they are sitting on the Berg Propulsion headquarters on the Hönö Island out in the Gothenburg archipelago. A nice place to be starting a discussion about marine installations, marine technologies, and marine vessels. The three persons joining me are first, I'll start with Johan Burgren, who is business manager for the marine segment. Then we will have Thomas Sailman, who is development engineer. And last but not least, we will also be joined by Andreas Bodén, who is the director for sales and marketing at PowerCell Sweden. We have received over the years many questions from you customers out there regarding fuel cell electrification and fuel cell solutions for the marine segment. And obviously, we want to start in sort of the end that is pretty much the obvious one. What type of vessels are these type of solutions suitable for? And I want to start by asking that question to you, Johan. What do you say? What type of vessels do you think are the most suitable ones for this type of technologies?
Yeah, thank you, Morten. Typically, the early adopters for fuel cell technology would be the ones that have the most local impact of zero emissions. So fixed route ferries, like the ones that are operating behind us here at the Hönö Island. We have coastal applications, we have cruise ships, typically sailing in and out of fjords. Those will be the ones that actually will be the early adopters as we see it.
Is there any specific areas where you see this will take place, or is it just pretty much anywhere where these types of ships are operating?
Yeah, typically local emissions, local impact, where you have local zero emission requirements. That's where these vessels will be operating. So in Norwegian fjords or in cities, sensitive areas like in the Arctic, for instance, where you go on exploration cruise, that could be early adopters.
Talking about these specific areas, and you were mentioning, zero emissions kind of solutions areas. What are the drivers here? I mean, we have heard of a lot of legislative demands that are being put into effect, not the least locally, but we also have the legislation, or rather the regulations that are coming from the International Maritime Organization. Now, how will that play into this?
Obviously, the IMO is consisting of member states, and it's up to the local sort of regulative or legislative authorities that actually will institute these regulations locally and to be the ones that actually take the lead in the implementation on local zero emission requirements. So for instance, in the Gothenburg harbor, there will be a need for zero emission in the future, since there is land-based applications running on zero emission solutions. So why shouldn't the maritime move in the same direction?
You did mention the Norwegian fjords before, and we all know that the legislative or the regulations that are being put into effect by IMO, it will not, come into effect until 2050. But when we talk about the Norwegian fjords, it will start much earlier. Isn't that the case? And why are the reasons why they're moving in this direction in Norway to start with?
They are really ambitious in Norway and really bold, I would say, in implementing these requirements. And I would say by 2030, that's the threshold for where you have to sail zero emissions into the World Heritage fjords in Norway. So that's the timeline we're talking about now. So it's time to start to look at these technologies going ahead.
No, I was going to say, because 2030, that's in 7 years, and the service life of these types of vessels is much more than that. So basically, this will have to start happening now. So are we ready for that?
Absolutely. And I think that Thomas will explain more about the details of our technology, and it's ready for the market, and we're there to deliver.
Another obvious question in this context is, of course, what type of installation we're looking at. I mean, Are we looking at full propulsion, or what are we starting with? Are we starting with some sort of auxiliary power unit, just for making sure you have power generation on board, or what are we looking at?
I mean, the beauty of electrification of a propulsion system is that you can use it for different kinds of things on board. You can use it for hotel loads, for different type of equipment. You can use it for slow steaming of propulsion. So typically in and out of the fjords, they will move in 8 knots, for instance, on 0 emission, sailing in and out. So you can use it for different purposes on board.
And if you look at it at types of vessels you talked about before, where you said that you think that these are the types where we'll start first, and what type of utilization will be the ones that you will start with? Will it be the hotel loads, or will it be a combination? What do you think? What do you see from your customer demand side?
Yeah, exactly. It's going to be a combination. So when you're mooring, you're using it for hotel loads, auxiliary loads. And when you're moving, you're using slow steam function, and it's gradually going to increase since the technology is evolving and you get more energy storage on board in terms of hydrogen storage and so forth.
Talking about hydrogen storage, another obvious question, of course, for you is, okay, so the technology is there, but is the fuel there? I mean, is the hydrogen there? What do you say? What is your answer to that question when the customers ask that?
It's quite obvious that the infrastructure of hydrogen has to develop. Now the land-based applications are moving in this direction. There is this very ambitious initiatives by the European Union, for instance. By 2030, it's not allowed to sell diesel cars anymore, and you have to move to the alternatives. So the availability of hydrogen will increase dramatically in the future, and the investments in hydrogen production is really now taking place as we speak. So this is gradually coming. And of course, you need to have the demand to be able to build the supply, right? So that's how we see it.
You're right. I mean, this is an obvious kind of hen and the egg question, and we have seen a lot of political commitment to this. You did mention here the European Union's initiatives when it comes to hydrogen production, but will that come along early enough for this to take off, or what do you foresee?
Certainly, for the early adopters, you will have more specialized solutions, bringing the hydrogen to these specific places, of course, or on-site production. But there will be solutions for the early adopters that you can move with today.
What about types of hydrogen here? I mean, there are all sorts of forms, but what everybody's talking about today is, of course, the green hydrogen, the hydrogen that is being produced with renewable energy sources. What do you foresee there? Will green hydrogen be something for the marine segment as well?
Yes.
Going forward?
Yeah, certainly. The green hydrogen is more sort of tapping into the existing hydrogen supply. That is so today you have this gray hydrogen or even brown hydrogen coming from different sort of dubious sources. But then moving into the future, when you have renewable energy build up, you have the capability of actually producing clean hydrogen, right? So that is gradually sort of mixing and blending into the future mix of hydrogen supply.
And what do you foresee there? Are we talking about gaseous, liquefied hydrogen? What are the types of hydrogen that will be most sort of commercially viable and used in sort of near midterm future?
Yeah, for the storage types, we're talking about storage types of actually how to store the energy and the hydrogen here. The early movers will be using both compressed hydrogen and liquid hydrogen. So liquid is cooled hydrogen, that is a liquid state, right? So these types will be dominating. And then there will be other hydrogen carriers coming into the picture in the future. But we see that more of a future scenario than right now.
And why is that? Why is it that this type of carriers will come into play going forward?
It's simply the maturity of the fuel cell technology itself, and Thomas will talk more about it here later in the presentation, but the maturity of the technology, to have hydrogen carriers, as we call them, like the e-fuels, the electro-fuels. Once those have been developed, you can reform the hydrogen out of this future e-fuel and use it in the fuel cell. But the maturity of the technology is much lower than the fuel cell technology that we use, right? So that's why.
But just make sure I understand you correctly. But if you were to burn them in the combustion process, you still would have problems with emissions like carbon dioxide, of course, but also other things like particulate matters and so, I guess. Or
Yeah, it's true. To some extent, you will always have emissions coming out. If you have a carbon atom in the fuel, if it's a hydrocarbon and you burn it, you will have emissions. Also, if you use them in fuel cells, to some extent, you will have emissions. So it will be not fully a zero emission usage, but it could be a net zero sort of usage in the application itself, right?
okay, so what is, if you were to talk about the typical questions that you do get from customers out there, what are they?
In terms of fuels, I mean, reforming of fuels is really on the agenda, but it's a bit too early, we think. The first installations we will have will be on clean hydrogen and pure hydrogen. That is the first sort of where the technology is right now. And for the future, there will be more reforming coming into play, probably when we're moving into long distance sailing, deep sea shipping, so those type of applications, moving into that area where we need a lot more energy. There we have the perfect fit for these fuels.
Very good. Thanks a lot, Johan. And I was happy to talk to you about this. Very interesting. I want to move over to Thomas Seilman, our senior development engineer here. We did have a discussion before this, before we started this webinar here, Thomas, and you said, it's ready. Tell us, what is it that is ready? Tell us a little bit more about the technology.
Yeah, thank you. We have been developing a Marine System 200 and it's ready. Our system is fully developed. It's able to be installed in parallel up into larger scale applications, and it's ready to be installed on a ship. There's no technical barrier to integrating this into current electric drive lines aboard vessels.
What do you think that it is that you don't hear that much about, fuel cell electric solutions in the marine segment when it has been around for quite some time?
Yes, hydrogen fuel cells have been around for, in one way or another, for 50 odd years. But yeah, it's been a long time coming. There's a lot of resistance in the industry. The marine industry is obviously a very slow changing industry. But now with the large focus on carbon emissions in the globe, in the world, there's a lot more push for these industries that are large emitters of things like carbon dioxide to switch to green fuels.
What is it, when you talk to customers, what is the typical kind of concerns they have when it comes to technical integration?
Yes, a lot of customers are simply unaware of how fuel cells work. You hear the obvious comparisons to batteries. So in some ways fuel cells are very similar to batteries, but in other ways they're very different. And so a lot of customers are just unknown about how fuel cells work, how they operate, and how to integrate them into a solution.
And what would you say? How complicated is it?
Well, it's not that complicated. We've taken care of all the difficult parts in the operation of the fuel cell, so from the customer's perspective, it's as simple as asking for power and receiving it.
I guess you get a lot of questions about, to what extent it can be used for main propulsion, or whether or not it can be used for just smaller things like we were talking about before, like auxiliary power and so on. What is the kind of typical setup that is being demanded by the customer here?
Yeah, so as you can see on the screen at the moment, here's our our Marine System 200. It's a 200 kilowatt module that can be put in parallel, there are 6 of them shown in this picture, which is a 1.2 megawatt installation. And these can be scaled up to any power range that is desired. So for things like hotel loads that were discussed earlier, you could get away with having a few systems, like 6 in this picture. But for main propulsion, you could scale it up to any number. We have an installation that we're working on that has got 16 of these for a 3.2 megawatt total power output.
It's sort of hard to say exactly how much is 3.2 megawatt, but if you were to try to put that into context, how much will that kind of power suffice to? What can you do with that? If you look at put into a boat of some sort.
3.2 megawatts is enough to propel a reasonably large boat for like slow cruising through things like harbours, or as discussed earlier, through fjords. It's not quite enough for main propulsion for ocean-going vessels, but the technology can be scaled up to that when the industry is ready for it.
Well, is there any limit to that? I mean, is there, and what is sort of the limitations here? Is it space, or what is it if you want to have really high power output?
Obviously, aboard vessels, space is always an issue. Weight to a lesser extent than other industries. But really, there's not that big of a technical barrier to scaling these up to very large multi-megawatt installations. There are some minor technical challenges, but these come with any technology, and these have got known solutions that we can use to overcome.
So that basically, I mean, you could have 100 megawatt kind of installation, or what do you foresee?
Yes, it could scale up to hundreds of, or 100 megawatt scale solution. One of the big challenges, as was discussed earlier, is the hydrogen storage. Obviously, you need to power all of these fuel cell systems, so you need the appropriate sized hydrogen storage to match the power system.
When we talked before, you did mention that sometimes you sort of stumble upon a lot of misconceptions about this technology. What are the typical kind of misconceptions that you do that you see?
Yeah, so very commonly hydrogen fuel cells get compared to batteries, since in some ways they behave similarly. But a fuel cell, it's more of a process that produces electricity. So it's not quite as simple as just pulling power whenever you see fit. The process has to ramp up in order to deliver that power. Now the ramp up rates are very quick, so we can get very close to matching real-time power usage, but there is still a process that needs to operate.
You mentioned battery electrification here, and an obvious way of looking at it from a sort of layman's point of view is to say, okay, so cars are electric by batteries these days to a large extent. Why not just use batteries and throw them into a marine vessel of some sort and use that instead?
Yeah, and there are solutions out there that have been looking into just battery electric vessels. However, a problem with that is scaling up to large energy storage. Batteries have a lot of challenges when you start scaling them up to very large volumes, and then you run into things like charging issues where it can take a long time to charge. Whereas with hydrogen fuel cell systems, when you have hydrogen either in a gaseous or a liquid form, you can typically refuel much faster than charging an electric battery.
I was going to ask you about the charging time and filling up time there, because if you look at the heavy duty vehicles like trucks and buses, and if you have a electrification with fuel cells, you pretty much get the same kind of sort of filling up times as with fossil trucks. What would the comparison be here when it comes to ships? Is it useful to make that kind of comparison, or what do you say?
In some circumstances it can be useful. However, quite often ships spend a lot of time moored at the port. So in some cases the charging time doesn't have that big of an impact, as long as we're talking about less than an hour maybe. However, if you're going to be charging very large batteries for very long ocean-going vessels, if you could even fit enough batteries on board, those could take a very long time, multiple hours, even into days to charge.
I have another question here for you. We were talking about, or rather, I was thinking about how combinations of technologies here, because obviously we need to combine different types of technologies. And one technology that is available out there is the diesel electric driveline. How does this technology, the fuel cell based technology, fit into that picture? Could you please elaborate a little bit on that?
Yeah, so a diesel electric drivelines in vessels, they use a diesel electric engine to generate electricity, which is then powering the ship. So there is a backbone of either DC or AC on the ship already in place. So in order to integrate a fuel cell system into this, it's as simple as connecting into that backbone. The power electronics for that already exist from some of the large marine equipment manufacturers, and they meet the specifications of the ship and of the fuel cell. So technologically speaking, there's nothing stopping a fuel cell system from tapping directly into that.
So this is really nicely dovetailing with each other here, and that kind of development will be just a good thing, given what you can do with the fuel cells.
Yes. So in that solution, because the electrical backbone already exists, you can just simply tap into it. There's no additional equipment required. There's no separate drive line, no separate motors to handle different power. It's just a matter of plugging it in.
Great. Thanks, Thomas. Thomas Seilman, our Senior Development Engineer at PowerCell Sweden. And now I want to turn to Andreas Bodén, who is our Director of Sales and Marketing at PowerCell Sweden, and talk a little bit about service and integration when it comes to this technology. What do you say, Andreas? What types of installations, do we see from a technical point of view here?
Of course, as we previously discussed a little bit, we have two options. One is, taking care of hotel loads, and the second one being for propulsion. And typically, the question we get from customers and the two solutions we foresee is either like a container-based solution on deck, or ship-specific in-hull installations, like the 3.2 megawatt we're currently doing for a leading European shipyard. And both of them can either handle an auxiliary power or a hotel load, or a primary or secondary propulsion mode.
If you were to sort of give us some more details or shed some more light on that, what is really the difference here? You're talking about container and in-hull installations. How might I understand the difference there?
If you take an on-deck installation in a shelter or a container, that would be something that is easy to retrofit an existing ship with, for example, connecting to a DC or an AC electric bus, for example. You don't probably need to bother so much about what's inside the ship. You need to have free space and that on deck, of course. A little bit simpler, I would say, from that perspective. The other one is an in-hull installation that requires, to occupy a certain space within the ship. You need to have the hydrogen supply going there. We need to have ventilation coming in, ventilation ducts to make it safe. Also process air for running the fuel cell, as well as the cooling system included inside the hull. So that would require more time, more engineering, and more work, of course, but probably more neater ship you get at the end compared to a shelter or container put on the deck.
If you look at it from a kind of application point of view, what would you use? What would be the typical way of using a container kind of installation and the in-hull installation? What are the differences?
I would say the on-deck installation, probably if you have an existing vessel, diesel electric, you want to put some fuel cell and hydrogen there, running hotel load auxiliary, putting some electricity into the electric drive, for example. You don't want to rebuild the whole ship. I would say it would be a reasonable, quick option for company or ship owners that want to, take the first step today. Or, if you want to do an in-hull installation, require, of course, more from the ship designer and the integrator and the yard doing that. But of course, that will be a slightly more sleeker option for the vessel.
One of your colleagues there before, he mentioned the 3.2 megawatt order that we have from a leading European shipyard. That is obviously not a container solution. Can you just sort of, add some color on what that is in this context?
That will be an in-hull installation that we currently doing. Of course, that requires more of the shipbuilder, the yard, the system integrator as well as our as fuel cell supplier, doing a safe and reliable installation in the ship with all this aspect that I previously talked about.
Andreas, I have a question here about serviceability. I mean, obviously, whatever type of drive line you have in the boat, serviceability is the key question for the customers. And how do you approach that when it comes to hydrogen electric solutions?
A good question, Morten. And we have had a lot of discussion with our customer, the potential customer, on how to do the service in a good way to don't interrupt the operation of the vessels, especially if the fuel cells are used for propulsion and not hotel loads. As Thomas mentioned, we have designed the Marine System 200 to fit into the marine environment. And as you can see in the picture, it's based on two modules, the 200. One will include in the fuel cell part, and the other one the media supplies. And those can be exchanged independent of the other 200 kilowatt modules in the vessel, which means we have developed this swing unit concept, as you can see in the picture here, where we, on a predictable service and maintenance schedule, continuously replace modules on individual Marine System 200s to keep availability for the operator on it, and that we don't need to go into the system and do, specific service or replacement of parts on board. We will do that, as you can see in the picture, on the refurbishment stage back at the manufacturing plant.
You mentioned maintenance here, and obviously, a question that pops up and comes to mind immediately then is, of course, maintenance intervals and service intervals. What do you foresee here? Do you know?
It totally depends on how the vessel will be operated. For a hotel load that are used now and then when going into harbors, of course, the service schedule will be less frequent because the usage of the system is not as regular and high. But if you're gonna run a passenger ferry or a ferry 24/7, of course, the service and maintenance we need to be very frequent and continuous to secure the availability and safe operation of the vessel.
You showed that picture here before of the Marine System 200, and it looks fantastic, of course. But a question that immediately sort of pops up is, what about installations, regulations, and this is we're breaking new ground here. What kind of regulations apply here, and when it comes to, for instance, safety and things like that? What does that look like?
You're right on it there, Morten. Safety is number one here, since we're talking about, first of all, new technology and also hydrogen, since you need to be careful of. So there is no specific rules and regulation and standards for hydrogen and fuel cell on board vessels today in the marine industry. But if you look on that, we are today here in the archipelago of Gothenburg, where the LNG marine industry developed 15 years ago, and that's where hydrogen and fuel cells are today, meaning that we need to follow the IMO's alternative design approach, where you do a risk-based assessment all the time. And we need to work close with the shipyard, the integrator, the operator, all the suppliers that needs to be involved, and of course this glass society at the end there, to doing a really safe and proper installation. So we will develop the codes and standard as we move on here, with implementing more and more installations on board of different type of vessels.
So not only will we be introducing new technology here and break new ground in that respect, we will also be developing new regulations as well along the way.
Yeah, we will develop the best practice for hydrogen and fuel cell installations as we move along here.
Very good, Andreas. Thank you very much. And thanks to all of you who have been watching and listening to this webinar. And thanks to our participants. Thanks to Johan Bugren, our business manager on the marine side. And thanks to Thomas Heilman, our senior development engineer. And finally, also, of course, thanks to you, Andreas, our director of sales and marketing at PowerCell Sweden. And if you have more questions or anything else that you would want to know more about, please turn to our employees. They are experts in this field, as you have seen yourself there. Thank you very much.